Hello students, today I am here to teach you chapter 22 in your textbook, that's sets. So we are identifying finite and infinite sets, and we write subsets of a given set, and you get to know what are equivalence sets, equal sets, disjoint sets and universal sets, and identifying intersection and union and complement of a set, and what are Venn diagrams. So you have already done this in last year. So what is a set? Set is a collection of distinct objects. So what you call these objects? Elements of a set. So here two words, elements and what is a set. Select sets and put a tick mark and put cross mark for those are not sets. Good children. You can't identify who are good children, so that's not a set. Odd numbers less than 10. 1, 3, 5, you can identify. So that's a set. Beautiful cities in Sri Lanka. We can't identify properly, so that's not a set. Months of the year, January, February, March, we know that. So we can count and identify. So that's a set. Vowels in the alphabet, A, E, I, O, U. That's a set. Multiples of 3 in between 10 and 20. So 3, 6, 9. So we can identify. That's a set. So we know how to identify what are sets. Look at the set A. What are the elements? A, B, C, D, E. Those are called elements. So we write elements inside curly brackets with commas. So A is an element of A because this one is inside the curly brackets. B is also an element. So there's a way of writing that. So we use this symbol to represent as an element. B is an element of A, or B belongs to A. X is not an element. X is not there. So how we can use a symbol for that? So we write this symbol and cross it out. So that means not an element. So how we write down element? You use this symbol. And not an element is this symbol. So we can write this is an element and when you cross it out, not an element. And you need to know another symbol. This one. There are 5 elements in set A. 1, 2, 3, 4, 5. So how can we write down that? Number of elements in A is 5. So N of something, you write the event there. This means number of elements. Number of elements. When we are writing elements, don't repeat here. Sometimes you get A twice. So we don't write twice there, just once. If B is 2, 3, 5, 7, what's NB? Number of elements in B. 1, 2, 3, 4. C is A, E, I, O, U. 1, 2, 3, 4, 5. That's NC is 5. If D is 1, 2, 3, so ND is 3. So we can count number of elements in any set. So there are 3 ways to represent a set. What are the 3 ways? Descriptive method. So in words you can write down what's the set. Writing elements within curly brackets. So what are the elements there? Or you can use Venn diagram. So Venn diagram, we use a closed plane figure and put the elements inside. Now take a look at this one. P is an event. Even numbers between 0 and 10. Between 0 and 10 means 0 and 10 both are not included. So what are the numbers, even numbers? 2, 4, 6, 8. So these are the elements, 2, 4, 6, 8. So we can write elements inside curly brackets. If it's a Venn diagram, what we do? We write these elements inside the closed figure. So 2, 4, 6, 8. So that's another way of representing sets. Write down the elements of the following sets given by descriptive method. Multiples of 3 between 0 and 10. So what are the multiples? 3, 6, 9. So you can't take more than 10. Letters in the word Maharagama. So what are the letters? M, A, H. A is there, but we are not writing again. R, A again, we don't write. G, A there, M already written, and A. So those are the different letters, distinct letters we have to write. Letters in the word mathematics. M, A, T, H. Then E, M, you can't write it again. A, you can't. T, I, C, S. Mathematics. Prime numbers between 10 and 30. What are prime numbers? So not divisible by any other number, but divisible by 1 and itself. 11, 13, 17, 19, 23, 29. So those are the prime numbers in between 10 and 30. Write down the number of elements in each set below. So you have to count how many elements are there. 1, 2, 3, 4, 5, 6. You can write 6 here. Here, these are single alphabet letters. 1, 2, 3, 4, 5. Signs. 1, 2, 3, 4, 5. Here, mathematical symbols. 1, 2, 3, 4, 5. And here, multiples of 3. 1, 2, 3, 4, 5, 6. So you can count and write down number of elements in each set. What is a null set? The sets with no elements are called null set. So now you are learning a new word, null set. What's a symbol we can use? We can use this symbol, chi. That's a Greek letter, chi. Or we can just draw the curly bracket. We are not writing anything inside, empty. It's empty there. So no elements, just 2 curly brackets. So we can use those 2 to represent a null set. Look at this one. A is an event, multiples of 11 between 1 and 10. You are not getting any elements. Multiples of 11 means starting with 11. So there are no elements. So A is a null set. So we can write like this or chi. So what's in A? No elements there. So that becomes 0. Odd numbers that are divisible by 2. All odd numbers are not divisible. So you don't get any number that is divisible by 2. So you can write this is an empty set or chi. So what's NB? Number of elements? 0. Whole numbers between 3 and 4? You can't find a whole number. You can find any decimal or fraction. So that's empty set. Or you can write chi. So NC becomes 0. Then you need to know finite sets. What are finite sets? Sets with specific number of elements are known as finite sets. Now think about this one, prime numbers between 0 and 10. What are the prime numbers? 2, 3, 5, 7. You can write for in between 0 and 10. So you can count 1, 2, 3, 4. So there are only 4 elements in this set. So therefore it is a finite set. Take a look at this one, multiples of 3 between 1 and 1000. So you can do that, but it takes time. Multiples of 3, 3, 6, 9, 12, 15, like that, 18, like that, less than 1000. So we know the last number is 999. That's the largest multiple of 3 less than 1000. So how many numbers are there? When you count, you get 33. So 33 multiples are there. So this is finite because you can count. We know that it takes time, but there's an end to that. We can count. So this is also finite set. Infinite set means sets with infinite number of elements are known as infinite sets. So that means elements cannot be stated definitely. Multiples of 3. So we don't know how far we have to write. There's no end to that. So those are infinite sets. 3, 6, 9, 12. Then what we do, we can put 3 dots to represent that this is continuing. All the elements cannot be stated. So this is an infinite set. Odd numbers. 1, 3, 5, 7, 9. We can't write all. So we can put 3 dots and close the bracket. All the elements cannot be stated definitely. So this is an infinite set. Select finite and infinite sets from the sets below. Decimals between 2 and 3. 2.1, 2.15, 2.1999. Any number you can write. So there's no end to that. So you can write any number of decimal places and write down any decimal number. So that's infinite. Multiples of 10 less than 100. 10, 20 like that you can write down. So that's finite. Prime numbers between 10 and 40. There's an end to that. You can write down. So that's finite. Letters in the English alphabet. A, B, C, D like that you can write. That's finite. Letters in the word carpenter. Yeah, we can count. That's finite. Letters in single alphabet. Yes, there are certain letters. You can count. Sounds of music. C, D, E. You can count. That's also finite. And odd numbers. When it says odd numbers, there's no end to that. So that's infinite. Equal sets. Sets which have the same elements are known as equal sets. The order of elements is not important, but needs to be the same elements. Look at A, T, E, A. To be B also equal set, you need to get same letters. So we'll write EAT, E, A, T. Order is different, but E, A, T. All 3 letters are there. So what can you say about these two? A is equal to set P. P is SET, set. So we can write TES. All three letters are there, elements. So we can say P and Q are equal sets. Digits in 2, 3, 4, 5. So 2, 3, 4, 5. Digits in 4, 5, 3, 2. You get the same digits. So what are the digits in 2, 3, 4, 5? 2, 3, 4, 5. What are the digits in Y? 5, 4, 3, 2. Same digits. So you can write X is equal to Y. Both two are equal sets. Now equivalent sets. If the number of elements in the two sets are equal, then they are equivalent sets. So elements are not equal. Here number of elements are equal. Look at A, B, C, D, E, A, E, I, O, U. 1, 2, 3, 4, 5. NA equals 5. So what is NB? 1, 2, 3, 4, 5. Same number of elements. So you can say NA equals NB. Number is the same. So we write equivalent sets. So we use this symbol to show that's an equivalent set. Look at X. 2, 4, 6, 8, 10. How many are there? 2, 3, 4, 5. Here in this one, 1, 2, 3, 4, 5. Same thing. 5 and 5. So these two are equal. So X and Y are equivalent sets. Identify equivalent sets from below sets. So we'll count how many elements are there. Maths. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And days of the week. How many days? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So 7 days are there. Now what can you say? What are the elements? So here, can you see? NB and ND are equal. Because of that, you can say these two are equivalent. Equivalent to D. Not these two. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Here, only 4. So these two are equivalent sets. Write down the elements of the sets below and identify equivalent sets. Prime numbers between 0 and 10. What are the prime numbers? 2, 3, 5, 7, 11. You can't write 11. This is up to 10. So 5, 7. First 7 letters in the English alphabet. First 7 letters. A, B, C, D, E, F. 1, 2, 3, 4, 5, 6, 7. Letters in the word cute. C, U, T, E. Vowels in the alphabet. A, E, I, O, U. Multiples of 5 up to 25. So 25 also included. 5, 10, 15, 20, 25. Now we'll count NP, number of elements in P. 1, 2, 3, 4. Number of elements in Q. 1, 2, 3, 4, 5, 6, 7. Number of elements in R. 1, 2, 3, 4. Number of elements in S. 1, 2, 3, 4, 5. Number of elements in T. 1, 2, 3, 4, 5. Now identify equivalent sets here, these two and these two. So you can say P and R. You can say P and R are equivalent sets, and these two, S and T, are equivalent sets. Select equivalent sets here. We have to just count number of elements in P. 1, 2, 3. In A, 1, 2, 3, 4. In B, 1, 2, 3, 4. And in C, 1, 2, 3. Now, what are the equivalent ones? These two and these two. So you can write P and C, equivalent sets, and A and B also. A and B are equivalent sets. So subsets. What are subsets? If all elements in one set is included in another set, then the first set is a subset of the second set. So then the first set is a subset. All students in a school. Students in grade 9. So we know those grade 9 students also in the same school. So all elements in B are in set A. So we say this is B is a subset. B is a subset of A. How can we show that? Mathematically. So we use the symbol this, a subset. So this means a subset of the other. Subset. Look at these three. So what is Q? 2, 4, 6. And R? 2, 4, 6, 8. Look at P. 2 is there, 4 is there, 6 is there. So P, all the elements in Q in P. Look at these two. We can say all the elements here also inside, and but not there. So what can you say? So you can say Q is a subset of R, because all the elements in Q in R as well. Then 2 again, 2, 4, 6 here, 2, 4, 6 here. So you can say Q is a subset of P as well. When you take R, can you write R? This is not a subset. Can you see? 8 is not there. All these elements not here. So how can you write not a subset? We cross it out. R is not a subset of P. We cross it out. R is not a subset of Q. So we can write this means subset. When you cross it out like this, not a subset. Multiples of 10 between 0 and 50. So you can't consider 0 and 50. So multiples of 10. 10, 20, 30, 40. Multiples of 5 between 0 and 60. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. You can't write 60. So all elements in A are in set B. 10, 20, 30, 40. All elements in A in set B. So how can you write down? A is a subset of B. So we can use this symbol. A is a subset of B. Now how can we make subsets? So you can write any number of elements. So when you take A is a set, what are the subsets? You can write each and every term separately. This is a subset A. B is also a subset. C separately also a subset. And you can take any two, A, B or A, C and B, C. All elements pairwise, AB, AC, BC, and also the same set is also a subset. So the given set itself a subset. So you can write ABC as well. Null set is always a subset of every set. So remember that null means no elements. So nothing, they are also inside here. So you can write nothing. So nothing means you can write without writing anything, just two curly brackets. So these are the all possible subsets you can get. X, Y, write down all subsets. You can take X separately, Y separately, X, Y itself and empty set. So all possibilities are there. Universal set. So universal, we use this letter epsilon. That's also a Greek letter, epsilon. So look at those sets. A is odd numbers less than 10. Odd numbers less than 10. 1, 3, 5, 7, 9. Even numbers less than 10. 2, 4, 6, 8. Prime numbers less than 10. 2, 3, 5, 7. Triangular numbers less than 10. 1. Then triangular numbers 1, 2, 3. Then you increase number of rows. 1, 2, 3, 4, 5, 6. Then you get 10. But less than 10, don't write 10 there. So 1, 3, 6. So look at these numbers. 1 is there, 2, 3, 4, 5, 6, 7, 8, 9. All digits are there. So what are those? Those are elements from Hindu-Arabic number system. The digits, we call those are digits. So we can say this 0, 1 up to 9, that's the universal set. Because all these are digits from Hindu-Arabic number system. So that's the universal set. Look at this one. Leela, Champa, Kamala, Rekha, Mala, Nayana, Tanuja. What is the universal set of above sets? What's that? Those are names of girls. So girls is the universal set. A, B, C, D, P, Q, R, A, B, K, L, M. What is the universal set of above set? That's the letters in the English alphabet. Venn diagrams. Elements can be written in a closed figure, and this was introduced by the mathematician called John Venn. So here, if A is a set, these are the elements. So what we do, we draw a closed figure. Normally we take circles to represent sets and put all the elements inside. A, E, I, O, U. And the universal set epsilon we denote in a rectangle. That's the universal set. So you can write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the universal set. So rectangle for the universal set, and for us just a set you can use circles. Look at this one. Epsilon means the universal set is given 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A is 0. So if this is A, this represent A, 0, 2, 4, 6, 8 inside the circle, the closed figure. But we know rectangle represent the universal set. So all the other numbers you have to put in outside the circle, inside the rectangle. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how we put all the elements in a Venn diagram. Ways of representing sets. Epsilon AB. Two sets are A and B. Look at these two. What is the first one? When there are common elements in A and B, this Venn diagram can be drawn. So when you know that there are common elements to both A and B, we put the two circles intersecting each other. If we know that there are no common elements in A and B, no need to put the circles intersecting. You can draw separately. So remember that when there are no common elements, you can draw like this. And if there are common elements, you can draw like this. Look at the first one. There's another small circle inside. So this means all elements in A, in B as well, because the circle A is inside B. So we say this is A is a subset. A is a subset of B. Now this one, B is inside. So B is a subset of A now. Then no circles inside, both are the same. That means both are equal sets. Intersection of sets. Intersection. So this set consisting of the elements which are common to all the sets is known as their intersection. So what is intersection means? Common elements. Look at P and Q. There are certain elements common. A. What else? I. That's all. A and I are common. So we can say P intersection Q is A and I. Those are the two common elements. So we can use a symbol for that. So what's the symbol for intersection? We use this U upside down. So this represents intersection. So what are the intersecting elements? That means common ones, A and I. So how can we represent these information in a Venn diagram. So P is there. So what are the common elements? So we write common elements for in this region. A, I. And P, you get E, O, U. And for Q, you get R, L, Y. So this is the Venn diagram, and shade the region intersection part. Where's the region? You can see this is the intersecting region. Look at this question. You have given the universal set 0, 1, 2, 3, 4, 5, 6, 8, 9 Hindu-Arabic number system, and A is given 2, 3, 6, 9. Show these elements in a Venn diagram and write down the set A intersection B. So this is given 0, 8 outside. So you can find out what are the digits in B from this. So first we'll mark A. 2, 3. If 2, 3 there, this should be 6, 9. Those are the two common ones, because that should be inside A as well. And 0, 8 is there. So we'll check the other numbers. 0, 1. And 1 should be there. 2, 3, 4, 5, 6 is here. 7, 8 is there. 9. So those are the elements in B. Now identify what are intersecting elements. 6 and 9. So 6 and 9. A intersection B. So you can shade and see what's the region. This is the intersecting area. Look at this one. You have given epsilon, Q and P. Write down the elements of each sets below. What's P? You have to look at the P circle. What are the letters? A, E, I, O, U. What are the elements in Q? That's inside the Q circle. A, E, X, Y, Z. P intersection Q, the common region. A, E. And what's epsilon? Epsilon means all elements. We can write A, E, I, O, U, A, E, I, O, U, X, Y, Z. Or you can write English alphabet. English alphabet, but you have to write all the other letters then outside. So write down the elements of each sets below. A, E, I, O, U, X, Y, Z. All elements belongs to universal set. Shade the region satisfying intersection B in below Venn diagrams. Common region for both. So what can you say about this diagram? You can shade this part. That's the common region. Second one, A is a subset. All the elements in A, in B as well. So common region is this. What's the common region here? B is a subset. All the elements in B, in A as well. This is the intersection. And AB intersection, both are the same. So that's the common region. Disjoint sets. What are disjoint sets? If two sets have no elements in common, then they are known as disjoint sets. Here, can you see two separate circles, no common elements. Show these in a Venn diagram. You have given epsilon is A, B, C, D, E, F, G, H. A is ACG. ACG. B is D, E, F. AC, ACG, D, E, F. D, E, F. What are the other ones? We have to put outside. B, B, H outside. So as there are no common elements in A and B, therefore we draw two separate circles. Look at this question. You have given the universal set X and Y. Show these elements in a Venn diagram. 2, 4, 6, 8. So there are no common ones. So AX is 2, 4, 6, 8. This one 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. And are there any extra digits? Yeah. 0, 2, 3, 4, 5, 6, 7, 8, 9. So only 0 outside. So this is a Venn diagram. Integers, positive integers, negative integers. So what are the integers you can take? 1, 2, 3, 4, negative 1, negative 2. All integers you can take. But P is positive integers. If it's P positive integers, Q is negative integers, there are no common elements. So this is positive. 1, 2, 3, 4, 5. All these you can't, there's no end. Q, negative ones. -1, -2, -3, 3, -4, -5. And there's no end to that. So negative and positive there. So 0 is not belongs to any set. So this is how we can represent positive integers and negative integers. There's no common elements. So what is P intersection Q? When there's no intersection, so that's a empty set. Or you can write the intersection is shy. No intersection. What is union? Now you learned a lot of terms. We did intersection, now union. So what is union? The set which consists of all elements in the sets is known as the union of sets. So look at A and B. So A union B means elements in A as well as elements in B, A or B. So we have to consider all elements in both as well. What's A? So what we do, we write first A. A, B, C, D, E, F. Then look at B and write down all elements. A, we have already written. E, written. I, we have to write. O, you have to write. And U. So when you write all elements, we say that's the union. A union B. So what's the symbol we are using? U letter like. So this symbol we use for union. So what is A union B? You write all elements A, B, C, D, E, F, I, O, U. Now how we represent that in a Venn diagram? A is A, B, C, D, E, F. What are the common ones? First we need to identify common elements in A and B. A and E. IOU not there. So A and E inside this. That's the intersection. Then we can write down the other elements here. B, C, D, F. In B, I, O, U. Now look at this one, it's not given the universal set. So universal set, we'll assume these letters are there. Now shade A union B means everything in A as well as everything in B means the area inside the two circles. So that's the union. A union B is everything inside the two circles. Shade A union B in the following Venn diagrams. So we need to color. We'll look at the first one. A union B. That means everything in this part, and this part. So that's A union B. So what about the other one? A union B. So that means everything in A, everything in B. Here, everything in here B is belongs to A as well. So this is union. Where's the union there? B is a subset. So everything in this part belongs to this one as well. So that's the union. What about the union here? So everything, these are equal sets. So this is the union. Write down the elements using the Venn diagram. So we'll write down all elements P. Where's P? You have to look at the P circle. B, A, C, D. Q. That's not. So I'll put Q here. This is Q. There's no B here, so that means this is Q. What are the elements in Q? A, C, E, G. P intersection Q. What are the common elements for both? That's in the middle, A and C. What are the elements in the union? P union Q means everything inside the two circles. You can write A, B, C, D, E, G. And what's epsilon? That's the universal set. You have to write everything inside the rectangle. A, B, C, D, E, F, A, B, C, D, E, F, G, and then K, H. So everything inside the rectangle. G, K, F, K, H. Look at this one. You have given X, Y. Show these in a Venn diagram. A, D, E. X is A, D, E. So here, can you see A, D, E? Here also. So that means X is the subset. So this is the subset, small circle. So we can write A, D, E there. Then the big circle is Y. So what are the extra terms? A, D, E. That means B, C, F. So you can write B, C, F inside Y but outside X. Then what are the other terms outside the big circle? So everything here except that you have to mark outside the big circle. So what are those? A, B, C, D, E, F there. G, H. G, H should be outside the big circle. That's the universal one. Now, answer these questions. X intersection Y. X intersection Y is a common region. That's A, D, E. X union Y means everything in X and Y. So, you have to write everything. A, B, C, D, E, F. look at this question. Write down the elements for the sets below. So you have given P, Q, R. What's intersection of P and Q? P and Q, common terms. B is common and D is not there. G is common. So you can write B and G. P intersection R. P and R, common terms. A, B, that's all. Q intersection R, that means common elements with Q and R, these two. B is common, and what else? That's all, only B. P union Q means everything in P and Q. So you can start with P, A, B, C, E, G, B already written, D, G is there, H. So you can write all the elements in P as well as Q and both, everything. Look at this Venn diagram. Write down the elements for the sets below. A intersection B. Common term, elements with A and B. Simple A and simple B. B intersection C. These two, common terms, elements X and Y. A intersection C. This circle and this circle not intersecting. So that means empty set or null set. So disjoint sets. A union B, that means everything in A as well as B. So you can write all the elements. A, B, C, D. And then P, Q, X, Y. So everything in these two circles. What is complement of A? Complement of A, the set of elements in the universal set which do not belong to the set A. We call complement of A. Look at this one. Epsilon is given 0 to 9, all the digits. A is 0, 2, 4, 6, 8. So what is A dash? That's a dash. Or sometimes in certain books we write bar. Bar sign also. That means same thing. A dash or A bar. Complement of A. Complement of A. That means not belongs to A. So A is, if A is 0, 2, 4, 6, 8, all the other numbers except that we call A dash or complement. So what are the other numbers? 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. So we put outside 1, 3, 5, 7, 9. So those are complement of A. So shade the region belongs to A dash. So what's the region? We close the circle A and shade outside. That's A dash. Look at this question. Write down the elements of sets below using the Venn diagram. So this is P and Q because this is given P and Q. Write down the elements of sets below using Venn diagram. P dash, everything outside P. So what you can do, you close the P circle and write down all the digits. What are the other digits? You get 6, 7, 8, 9, 0. 1 is also there. 0, 1. Here when you close this, 6, 7, 8, 9, 0, 1. And Q dash, you close the Q circle. So what are the other numbers? 1, 3, 5, 9, 0. So when you close Q circle, 1, 3, 5, 9, 0. Those are complement of Q, that means not belongs to Q. Look at this diagram A, B, C. Write down the elements for the sets below. A dash, close A and write down all the elements. 4, 1, 8, 9, 7, 6, 11, 12, 0. Order is not important when you write down elements. So close A and write down all the elements. 4, 1, 8, 9, 7, 6, 11, 12, 0. B dash. Now close B. What are the elements outside? 0, 1, 2, 3, 4. Here 2, 3, 4 here. 0, 1 and 11, 12. C dash. C dash is everything outside C. Close C circle and write down all the elements. 0, 1, 2, 3, 4. So 0, 1, 2, 3, 4, 5, 8, 9, 10. See whether we wrote everything. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's C dash. Now we'll look at the review exercise in your textbook. Determine whether each of the following collections is a set. Multiples of 4 between 0 and 30. So you can write down 4, 8 like that. You can identify. So this is a set. The districts of Sri Lanka, we know that. Colombo, Kaluthura, like that, we know there are several districts. So that's a set. Students who are good at mathematics. So there's no measurement to judge who are good students. So that's not possible. So not a set. Triangular numbers? Yes, we know that. 1, 3, 6 like that. Triangular numbers. A set. The 10 largest integers. Can we find out largest? We don't know. Infinity. We say infinity is the largest. So we don't know what's the 10 largest integers. So you can't identify that. Not a set. Write each set given below in terms of its elements and write the number of elements in each set to multiples of 5 between 0 and 20. Between means you don't consider 0 and 20. 5, 10, 15. B. And also here you need to count how many elements are there. NA. 1, 2, 3. B. Letters of the word. Reconciliation. So we'll write down R, E, C, O, N. C we can't write again. I, L, L, I, A. T, I we did, O, N. So you can't repeat the same element. So how many elements are there in B? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 9. Prime numbers between 2 and 13. In between 2 and 13 means you can't take 2 or 13. So 3, 5, 7, 11. Numbers between. So here count 1, 2, 3, 4. So NC is 4. This one D. Numbers between 0 and 20, which are a product of two prime numbers. 2 times 3, 6. 2 times 5, 10. 2 times 7, 14. Then 2 times 11, 20. So that's, you can't. Then 3. 3 times 5, 15. 3 times 7, 21. We can't write. Then 5 times 7. You can't take. So these are the product of prime numbers. Two numbers. Product of two prime numbers. So 1, 2, 3, 4. So ND equals 4. Whole numbers between 5 and 10. Write down elements. Whole numbers means integers now. Between 5 and 10 means 6, 7, 8, 9. You can't write 5 and 10. So how many? You don't need to count. It's just write the elements of D. Then find D here. ND is equal to 1, 2, 3, 4. 4 elements are there. Express the null set in 3 different ways using the above mentioned first method, that is by the descriptive method using a special characteristic. So what are the null sets? Can you give some examples? A is a set. Integers in between. Integers between 4 and 5. You can't find integers in between 4 and 5. So that's empty. Odd numbers that are divisible by 2. By 2 without a remainder. No odd numbers. Or you can write another one, empty set. Positive integers less than 0. Positive integers less than 0, because all are negative numbers less than 0. You can't get any element. So that's a null set. Example number 1. For each of the sets given below, write the elements and write whether it is a finite set or infinite set. Positive multiples of 6 less than 30. 6 less. Positive multiples of 6 less than 30. So starting from 6, 12, 18, 24, 30 you can't write. That's less than 30. Polygons. You can write triangle, quadrilateral, pentagon, hexagon, like that. 50-sided polygon, also polygon. 90-sided polygon, 100-sided polygon. So there's no end to that. So we can write triangle, quadrilateral. We can write some. Pentagon, hexagon. So there's no end. N-sided polygons are there, so we put 3 dots to represent. That's not ending. So P is a finite set and Q is infinite set. Example number 2. Odd numbers between 0 and 10. What are odd numbers between 0 and 10? 1, 3, 5, 7, 9. Vowels in the English alphabet. A, E, I, O, U. Those are vowels. By writing the elements of these sets, show that they are equivalent sets. So what you have to do in equivalent sets? Number of elements we are checking. If the number of elements are equal, those are equivalent sets. 1, 2, 3, 4, 5. NY is 1, 2, 3, 4, 5. So what can you say? So NX is equal to NY. So X is equivalent set Y. So although all pairs of sets are equivalent, all pairs of equivalent sets need not to be equal. So we know that these two are not equal. X is not equal to Y because elements are different but equivalent. Exercise 22.1. From the sets given below, select and write the finite sets and the infinite sets separately. A. Multiples of 5. From 0 to 50 means 0, 50 included. So starting from 5. 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50. Up to 50 means 50 you can write. Integers. We write integers. So here we can write any integer, negative integer this side. And we'll write sum of the integers -3, -2, -1, 0, 1, 2, 3. You can put dots here because positive integers also we can't write. So that's an infinite one. See? Numbers that can be written using only the digits 0 and 1. So what are the digits you can write? The numbers that can be written 0 and 1. There is no end. You can write 0, 1, 0, 1, 1, 0. Then 1, 0, 0. Likewise, it's never ending. 1, 1, 0, 0, 0. Any number with 0 and 1. 4. Digits of the numbers. That means 2, 5, 6. So there's an end to that. 2, 5, 6. E. Positive integers which are not prime. Positive integers which are not prime. So 1 we don't take. Positive integers. So 1 is not a prime number, so we can consider that. 2, 3, 4 you can consider. Likewise, there's no end. So 4, 5 you can't take. 6, 7, 8, 9, 10 like that. You can take any number. So what are finite and infinite? So we can say first one is finite. There's an end to that. This one, infinite. This one also never end. Infinite. This one, finite. And here, infinite. Write each of the following sets in terms of their elements and then write all pairs of equal sets and all pairs of equivalent sets. So we first write down all the elements. Positive multiples of 3 below 10. 3, 6, 9. Q, letters of the word net. N-E-T. R, odd numbers between 0 and 10. 1, 3, 5, 7, 9. S, digits of the numbers 3, 6, 9. T, vowels in the English alphabet. A, E, I, O, U. And V, letters of the word 10. T, E, N. Now we need to identify equal sets and equivalent sets. To find out equivalent sets, we need to find out number of elements. In P is 3. In Q, 3. In R, 1, 2, 3, 4, 5. In S, 3. 1, 2, 3, 4, 5. In T, that's 5. 1, 2, 3. In B, that's 3. Now we can identify. What are equal sets? We can write down equal sets. Here 3, 6, 9. 3, 6, 9. Can you see P and S? Same elements. P is equal to S. Then NET, NET. These two are equal. Q and V. And the other ones are not the same. And now we'll find out equivalent sets. That means numbers are equal. See, P, Q, S, V. All are equivalent sets. And these two, R and T, equivalent. 5 and 5. Same number of elements are there. Write 3 examples of finite sets. So you can write finite sets. So you have to give a condition. So odd numbers less than 10. So that's finite. Vowels in the English alphabet. Vowels in the English alphabet. You can write down. What else? Letters in the word. Mathematics. So that's also finite. You can write down the elements. Write 3 examples of infinite sets. So you have to write down odd numbers. Then we are not giving a condition. So you can't write all odd numbers. Odd numbers. Or multiples of 3. You can't write all multiples. What else? Numbers that can write with digits 2, 3, 5. So that's a lot. Write 3 sets which are equivalent to the set 2, 3. So equivalent means any 2 possibilities are there. So 2 elements equivalent. So we can write P is A and B. Q is 1, 2. No need to be the same elements, just the number of elements should be 2. Or you can write, what are the other? You can write anything. X, Y. Only 2 elements are there. Example number 1. Multiples of 6 between 0 and 20 and multiples of 3 between 0 and 20. Write the elements of each of the above sets and select the subset. Multiples of 6. 6, 12, 18. Between, you can't take 0 and 20. Q. Multiples of 3. 3, 6, 9, 12. 15, 18. So you can't write 21. So which one is a subset? We can see 6, 12, 18 belongs to Q as well. So P is a subset of Q. Write all the subsets of the set X, 1, 2. So you can write X1. Separate elements. 2 or both. Set itself a subset. And last one is an empty set is always a subset of a set. Write all the subsets of the sets Y. So what are the possibilities? Y1, 3, Y2, 5, Y3, 7, Y4, you can write now 2 elements, 3, 5. Then Y5, you can write 3, 7. 3, 5, 3, 7, then Y6, 5, 7. And then Y7, I can write all together the set itself. 3, 5, 7. And finally, I can take the empty set. Write a universal set for A. 2, 4, 6, 8. So I can say universal is digits, all digits in Hindu-Arabic number system. So universal set is, I can write digits, or I can write all digits like this. 0, 1, 3, 4, 5, 6, 7, 8, 9. Exercise 22.2. Write 8 subsets of the set. This one, 8. You can write separately. 2, 5, 13, or I can write 2. 2, 5. Or I can write 2, 8. You don't need to write all, so I can write 3 digits, 2, 5, 8. So any 8 subsets. Determine whether each of the following statements true or not. 1, 2, 3 is a subset of numbers divisible by 5. Numbers divisible by 5 means 5, 10. So 1, 2, 3, not. So not true. 4, 9, 16 is a subset of square numbers. Yes, those are square numbers. That's true. Cylinder is a polygon. Polygons are triangles, not 3D objects, 2D figures. So triangle, quadrilateral, pentagon. So cylinder is 3D. So not true. Red color is the colors of the rainbow. Yes, red is a color there, so that's true. Solution of 2x minus 1 equals 7 is even numbers. So just find out the solution. When you take minus 1 to this side, you get 2x equals 8, x equals 4. Even numbers. So you get even numbers. Yes, x equals 4. That's true. Write a universal set for the set A, E, I, O, U. Can take as letters in English alphabet. For each of the following parts, name a suitable universal set such that the given sets are subsets. So these two, we have to give one universal set. Here, it should be 1000. You can't write same number twice. So I can write multiples of 5 because this is also multiple of 5. This is also multiple of 5. Multiples of 5. Countries with more than 90% literacy and countries which are not bordered by an ocean. All countries. All countries. January, March, May, August and months with 31 days. Months during which the members of your family celebrate their birthdays. All about months. You can write months in the year. Example number 1. You have given the universal set and A. Represent the above sets in a Venn diagram. So you have to draw the rectangle to represent the universal set. And A is a sum. Just a set inside. So 2, 4, 6 is inside A. Other numbers outside. 1, 3, 5, 7. 2, 4, 6, 1, 3, 5, 7. So represent. So that's how we can represent the Venn diagram. Example number 1. Students of Kannangara Vidyalaya who play cricket. Any students of Kannangara Vidyalaya who play football. Write the set MN intersection N in descriptive form. What is intersection means? The common region for both. So same school, Kannangara Vidyalaya. First one is play cricket. The other one is about football. So what's the common one? Play both cricket and football. So you can write M intersection N as students of Kannangara Vidyalaya who play cricket and football. So that's the intersection. Write the following two sets by listing their elements and then find their intersection. Represent all the elements in a Venn diagram. So first, write down the elements. Prime numbers between 0 and 10. Prime numbers 2, 3, 5, 7. And here Q, odd numbers between 0 and 15. Between means 15 is not included. 1, 3, 5, 7, 9, 11, 13. Now we can represent this in a Venn diagram. First of all, we have to check whether there are common elements. 3, 5, 7. There are common elements. So when you are drawing the two sets, common elements are there. So that means we draw like this. This is P, this is Q. Now we'll put all the elements inside. What's common? 3, 5, 7. So 3, 5, 7 inside this region. That's common. Then 2 inside P. 1, 9, 11, 13 inside Q. 1, 9. So 3, 5, 7 common, 9, 11, 13. So that's the universal set. This is the rectangle. So we can just write, if the digits epsilon is all numbers, counting numbers, other numbers you have to put outside, but we don't know, so we can draw like that. Here it says, then find their intersection. So I have to write that also. The intersection Q we put inside, but we didn't write 3, 5, 7. So that's the intersection of P and Q. Prime numbers between 0 and 10. Odd numbers between 0 and 10. Write these sets in terms of their elements and write. So here another error. Union. So this should be Q. P. What are the prime numbers between 0 and 10? 2, 3, 5, 7. Odd numbers between 0 and 10? 1, 3, 5, 7, 9. Write these sets in terms of the elements and write P union Q. P union Q means you have to write everything in P, Q and both. So we write first 1, 2, 3, 5, 7, 9. All elements are there. Furthermore, express the union in terms of a common characteristic of its elements. So what's that? That means you have to write all in P and Q as well. Example number 2. X is students in Kannangara Vidyalaya who play cricket. Students in Kannangara Vidyalaya who play football. So union is what? Students in Kannangara Vidyalaya who play either cricket or football or both. Now see how you write down. This is either this or both. Now let us see how to represent the union of sets in a Venn diagram. So here, if you are drawing a Venn diagram, this one, cricket, let's play cricket. So here it can be both as well. This is play football. So this is epsilon. You can take students in Kannangara, students in Kannangara Vidyalaya. So that's XY and union. How you represent? This means only play cricket. This is play both cricket and football. This is only football. So altogether, that's the union. Example 3. Answer the given questions based on the following Venn diagram. Write set A in terms of its elements. What's A? A is 2, 4, 6, 10. 2, 4, 6, 10. Write B in terms of elements. B is the circle B, you have to look. 1, 2, 3, 4, 7. 1, 2, 3, 4, 7. Write the universal set in terms of its elements. Universal set, that's everything. 1, 2, 3. 4 is there. 4, 5, 6, 7, 8, 9, 10. Up to 10, all the digits are there. Express A intersection B. A intersection B means common ones, 2 and 4. Express A union B. A union B means A or B or both. 1, 2, 3, 4. Inside the two circles. 1, 2, 3, 4. 6, 7, 10. 6, 7, 10. Example number 4. Represent the above sets in a Venn diagram. Express P intersection Q, P union Q in terms of their elements. Okay, so we need to draw the Venn diagram. Are there any common elements? So that means first thing you have to identify that. What are the common elements? 3, 4, 5. Now you can draw the two circles that's intersecting because there are common terms. PQ and 3, 4, 5 inside. In P, 3, 4, 5, that's 1 and 2. In Q, nothing here because 3, 4, 5 there. So that's the Venn diagram. And you need to give P intersection Q. We gave what's P union Q. Everything in P or Q or both. 1, 2, 3, 4, 5. Exercise 22.4. The sets P, Q and R are defined as follows. Express each of the following sets in terms of its elements. P intersection Q. That means common terms for P and Q. 1, 6, 8. P intersection R. P and R. Common terms. 3, 10. Q intersection R. Q and R. Nothing common. So empty set or null set. P union Q. That means you have to write everything in P or Q or both. 1, 3, 6, 7, 8, 10, 30. P union R. Everything in P or R or both. 1, 2, 3, 6, 8, 9, 10. P and R. 12, 13. Q union R. Q and R. So everything 1, 2, 3, 6, 7, 8, 9, 10, 12. In these two. You have to write everything. The sets A, B and C are defined as follows. Counting numbers, prime numbers and factors. Write each of the above sets in terms of its elements and write each of the following sets in terms of their elements. So first you have to write down what is A, what is B and C. So we'll first write what is A. Counting numbers from 1 to 12. That means 1 and 12 also included. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are counting numbers. B. Prime numbers less than 10. 2, 3, 5, 7. And what's C? Factors of 12. 1 is a factor. 2 is a factor. 3, 4, 6, then 12. Those are factors. Now we can answer this. A intersection B. A and B common. 2, 3, 5, 7. And A and C intersection. 1, 2, 3, 4, 6. B intersection C. These two common terms. 2, 3. That's all. A union B. Everything in A, B or both. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Everything you have to write. A union C. So up to 12 you have to write everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. B union C. Common term. Not common. All in B or C. 1, 2, 3, 4, 5, 6, 7, 12. So in these two. So that's how we write down union and intersection. Consider the Venn diagram given below. Write each of the following sets in terms of its elements. What's A? Inside A circle. 2, 3, 5, 7, 9. B? Inside B circle. 1, 3, 4, 5, 7, 8. A union B. Everything inside the two circles. 1, 2, 3, 4, 5. And then 7, 8, 9. And intersection, A intersection B, only this common part. 3, 5, 7. Example number 1. By considering the given universal set and its subset B, write the set B in terms of its elements. So we can write considering this one. So 5, 10, 15, 20, 25, this one. B is this 10, 20, 30. So write whether it's a subset. So 10 is there, 20 is there, 30 is there. So B is a subset of the universal. Write the set B dash. What's B dash? All elements not belongs to B. So not belongs to B but in the universal set. So 5, 15, 20, 25, 35. So you can write all the other elements except the elements in B. Example 2, birds. That's the universal set. Birds that make nests. Then write P dash in descriptive form. So if this is P, so this is the outside, P dash. So how can you write P dash? Birds that do not make nests. You can write down the opposite. Do not make nests. Find the following using the information in the Venn diagram. P dash, outside P, 2, 6, 15, 18, 20. We have to close the P circle. Q dash, close it and write down all the elements outside. 2, 4, 6, 7, 12, 18. 2, 4, 7, 12, 18, 6. The intersection Q, common part 5 and 10. P union Q means everything inside the two circles. 4, 5, 7. 4, 5, 7. 10, 12, 15, 20. Those are the numbers inside. Exercise 22.5. You have given 3 sets. Write each of the following sets in terms of the elements based on the above given information. A dash. A dash means not Sakindu, Pavindu. Then it can be Ravindu, Pavindu and Sakindu you can't take. Ravindu, Sanindu, and Mithindu. B dash, not B, not Ravindu, not Sanindu and not Mithindu. So it can be Sakindu, then Ravindu, Sanindu, Pavindu you can take. C dash, not belongs to C. Sakindu, Sanindu, Pavindu. Sakindu. So you can write Ravindu there. Sakindu you can't take, Sanindu you can't take, Pavindu. So Mithindu. A intersection C. Common for A and C. What's common? Sakindu common, Pavindu common. Sakindu and Pavindu. A intersection B. This one, these two. Sakindu, Pavindu, Ravindu. So no intersection, no common term. So that's an empty set. B intersection C. What's the common? Ravindu, Sanindu. Sanindu is common. That's all. Sanindu. You have given the universal set PQ. Represent universal P and Q in a Venn diagram, and using the Venn diagram write each of the sets given below in terms of its elements. So we need to first draw the Venn diagram. This is the universal set and you get two sets. Now first of all look at the numbers and see whether there are common ones. 1, 3, 5. 5 is common, 7 is common. 5 and 7 common. So when you are drawing the two circles, so you have to put 5 and 7 inside. So this is P and this is Q. Now we'll put the numbers. P is 1, 3, 5, 7, 9, 10. What's Q? 2, 4, 5, 7, 8. Now all the other numbers you have to put outside. 1, 2, 3, 4, 5, 6 is not there, 8, 1, 8, 9, 10. So only 6 outside. Now we can write down P dash not belongs to P. 2, 4, 6, 8. Q dash not belongs to Q. Close Q circle. 1, 3, 6, 9, 10. 1, 3, 6, 9, 10. P intersection Q. Common for both. 5 and 7. P union Q means inside the two circles. 1, 2, 3, 4, 5, 6 you can't write. 7, 8, 9, 10. By considering the Venn diagram given below, write each of the given sets in terms of its elements. X. Only consider X circle. 2, 7, 8, 11, 14, 21. Only X circle. Y circle. 7, 10, 14, 17, 21. X intersection Y means inside. 7, 14, 21. X union Y means both the circles. 2, 7, 8. Then 10, 11, 17, 14 also you have to write. 14, 17, 21. X dash, everything outside X. 5, 9, 5, 9, 10, 10, 13 also you have to say. 5, 9, 10, 13, 17, 20. And Y dash, everything not belongs to Y. What are the numbers? 2, 8, 2, 5, 8, 2, 5, 8, 11, 9 also there, 9, 11, 2, 5, 8, 9, 11, 13, 20. Now we'll look at the miscellaneous exercise. Represent the following information in the Venn diagram. So two separate ones means disjoint sets. P 2, 4, 6. So just put the numbers. 1, 5, 8. And all the other numbers in the rectangle outside the two circles. 1, 2, 3, 4, 5, 6, 7, 8. Write each of the sets given below in terms of its elements. P intersection Q. Nothing there. So that's an empty set. or you can write shy. P union Q, everything in P or Q. 1, 2, 4, 5, 6, 8. P dash, everything outside P. 1, 3, 4, 5, 7, 8. And Q dash, everything outside Q. 2, 4. 2, 3, 4. Here I have done a mistake. So here 4 is not there. So I have to delete 1, 4. So 2, 3. Everything outside Q. 2, 3, 4, 6, 7. So first again check 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's correct. Include the elements in the following sets in the given Venn diagram. 4, 10, both common, so it's inside. Then P is here, so 2 is this one. Then inside Q I can put 3, 4, 8, 10, 3 and 8. Then what are the numbers outside? 2, 3, 4, 5, it's not there, 7, 8, 10, 12. So you have to write all the other numbers outside. Answer the following based on the information in the Venn diagram. Write set A in terms of its element. What's A? A is the big circle. So 2, 4, 5, 6, 8. 2, 4, 5, 6, 8. B is small circle, 4 and 8. Right, set epsilon means the universal set. So everything. 1, 2, 3, 4, 5, 6, 7, 8. 1 to 8. A intersection B. Common term for A and B, that's just B. 4, 8. A union B. Union B is just everything here, that means in A. All elements in A is A union B. So you can repeat A. 2, 4, 5, 6, 8. A dash, that means complement of A, not belongs to A. So outside the A circle, 1, 3, 7. So we covered all theory related to sets. So sets with finite number of elements are called finite sets. Sets with an infinite number of elements are called infinite sets. Sets with the same elements are called equal sets. And sets with the same number of elements are called equivalent sets. A set which contains all the elements under consideration is called universal set. So can you remember the symbols? Epsilon universal set. And then this symbol for intersection, this symbol for union. And complement, we put A dash. So study all theory related to sets because this is a really important lesson and we are continuing this in grade 10 and 11.